Hey, Shenango STEM Gadget Open Housers, it's Mr. Drzezinski, and I'm going to make a video for our open house this year for the STEM Gadget class. I'm down here in the STEM lab. Let me use the camera and show you the room that we use here. We have a section right here that allows us to do our coding. It's kind of a computer area. STEM Gadget spends a lot of time in here. We can make our circuits, do our grade request sheets, and print them from there. Equipment, there's a cabinet there with all the STEM Gadget equipment. Those are mostly electrical components. This is the old wood shop that we turned into a maker space. We have some 3D printing machines in here, as well as the CNC router, and then the engraver as well as in here, and our large format printer. These are the 4 spaces we use for all of our STEM classes. And let me introduce all of the parts of the class, how students get grades, and what we're expected to do here. I started a college program in 1980 called Industrial Arts Education, if any of you remember that. But by the time I graduated, it was referred to as technology education. Technology education only went for about 30 years now. It has turned to STEM education. That's science, technology, engineering, and math. The STEM Gadget class was designed to have students build an autonomous electromechanical device. Autonomous means that it runs by itself. Electromechanical means that it's made of electrical parts and mechanical parts. Students will be introduced or reintroduced to the engineering design process, where they're to identify a problem, do the research and brainstorm ideas, create a plan to build a prototype, build the prototype and test it, and then improve on it and learn from it. We'll be using the Arduino printed logic control boards. The Arduino is a very general device which allows us to attach sensors on the near side and actuators on the far side. They'll be building circuits with breadboards and wiring. They learn about open and closed circuits and series and parallel circuits. The types of actuators students will be involved with: LEDs to turn lights on, or strings of lights can be programmed. They'll turn on audio buzzers or chimes. They can start motors, start and stop motors. We also have liquid crystal displays, which they can print out words. The sensors that we use on the near side include touch sensors. So if someone touches this device, it'll send a signal to the Arduino that can make something happen. Photo sensors will detect light, and color sensors will detect different colors. We have thermal sensors to detect heat or humidity. Ultrasonic sensors, which can detect how far away a certain surface or object is. We have motion sensors that'll detect if something's moving near the sensor. And then there's fingerprint scanners, which allows them to read fingerprints. But all of these sensors are put on the near side of the Arduino board. The actuators can be put on the far side. The Arduinos are programmed with their Arduino programming language, and little devices can be made. Similar devices that you may have in your house on your stove or your wash machine and those sort of things. The class in general doesn't have to make any particular project. Students are to pick their own projects. So for instance, if they wanted to pick a project like you would see at Halloween, where if a person is walking down the street and then an arm might jump out from a box or a can or something, the motion detector might detect the motion of the person walking down the street, and then it deploys maybe a pneumatic to send an arm up in the air. Those are some things, and I'll show you some other things some students have done in the past. But the philosophy with STEM is that the students decide themselves on what they want to do, their project and their learning objectives. The teacher pretty much is the facilitator, which supplies the equipment and the direction. We use a lot of resources from the internet to learn different subject matter. We've had people in the past build drones, program lights, like you might program lighting on a Christmas tree. Each of the lights on the tree can be programmed to come on and off with a different color. The clapper was done, and that senses somebody clapping in the room to turn a light bulb on. That's something that you might have seen a product on television. We can make any little Land Rovers, metal detectors. Someone created like a landmine simulation, where as it moved across the ground, it detected anything metal. We also have fingerprinting devices, which will maybe only allow a certain person into using the system. That's pretty interesting. We had a sonar that allowed, like a fish finder would use, which allow you to find something under the water. We also have wireless connections where people can program their Android cell phones to coordinate some activity with the um, Arduino board. So, for instance, people are using their phones to call their houses to unlock or lock garage doors or something of that nature. Liquid crystal displays allow us to maybe print out a message or a timer for a timing event. But these pieces of equipment lend themselves to doing all sorts of different projects and exercises. Students are really encouraged to build and use whatever tools and materials necessary to build devices and program and troubleshoot. And it's a little bit of engineering as they go through. In order to get a grade for the class, all the student has to do is write grade request sheets. The grade request sheet is something they can find online, and they put their name and the date and so on there. They'll pull off an objective from a library of objectives. We have objectives related to science, technology, engineering, and math, as well as character and career objectives. And as they pull one of these objectives off, they have to specify what it is they did in class to achieve the objective. So early in the class, we put circuits together with breadboards and LEDs and wires to a battery. They build a little circuit. They go to the objective about building an electrical circuit and describing the parts and functions. And they can take a picture of their circuit and then type out the text necessary to describe the parts and functions. And then they'll get credit for that. And there's really no tests and there's no losing points. There's just writing these grade request sheets and collecting and getting more and more points. Um, to get a letter grade, I have assigned a certain number of points that they have to get per week, but they can get many, many more points per day or per week that they wish. And then the numbers will be associated with letter grades 90, 80, 70, and 60. We can do communications through Parent Square and Student Square, which is typical for the school. Grades are located on CSIU, which is typical for the school. And I have a Drzynski homepage, which I will put the link on their Google Classroom. But the Drzynski homepage has the objective files and the grade request sheet file, as well as a course syllabus on there if students need those resources. We do have a Google Classroom. Hopefully we can meet in the STEM lab, because anybody that's at home, either quarantined or has to work through the Google Classroom, it's much more difficult to do those things than being here at school. I had last year, for the people that had to stay at home, the ability to give them a box of equipment, and they can use the equipment at home and do work there as well. Okay. Let me know if you need anything. I'm looking forward to working with the students to be successful to build these little autonomous electromechanical devices using the Arduino and the other pieces of equipment. And it's sort of a different philosophy in terms of grading, because they have to do these grade request sheets. But if you'd like to look at the grade request sheet or the objective list, they are on the Drzynski homepage, and I can give you that link, or you'll find it in the Google Classroom. And let me know if you need anything else. Thank you.